Hello everyone, my name is Han Lee and I'm a first year PhD student here at University of Texas at Arlington. I'm currently working in Dr. Shuk lab. Today I will present targeting odorless compound in municipal solid waste using canister sampling. The emission of trace gases from landfill that contain municipal solid waste has emerged as a pressing concern for both environmental sustainability and human well-being. These gases stemming from the decomposition of waste, direct release of chemicals, and chemical reaction within the landfill exhibit varying composition of different stages of decomposition. Moreover, they are dispersed during waste management procedures and from the landfill's cover system. Within the landfill gases, the spectrum of odorous compounds exists, including volatile organic compounds, sulfur and nitrogen-based compound, and volatile fatty acid, albeit in minimal concentration in raw landfill gas, and trade gases emerge from biodegradation of organic material, volatilization of compounds, and chemical reaction that take place within the landfill. They transport from the most during compaction, compression, and dumping processes of waste, also depending on the cover system of landfills that may contribute to the transportation of gas. Not a lot of methodology that were done to address in the issue of odorous compound, the Environmental Protection Agency method, and the American Society of Testing Material primarily focus on hazardous waste and safety rather than odors adore others. Also, these methodologies also focus on detecting specific odorous compounds based on their functional group, because targeting specific odorous compounds that are not addressed by existing methods that are more concerned with air pollution and safety. The methodology developed aims to collectively identify 43 odorous compounds instead of categorizing them into groups. A critical aspect for this method lies in determining the limit of detection LOD for this compound, and is paramount for the LOD to align the threshold of human olfactory perception, ensure that odor can be detected as effectively as the human nose. Therefore, establishing the LOD served as a pivotal evaluation of the method efficacy in detecting odor with the same range as human olfaction. The gas chromatography triple quadruple mass spectrometry, GCMS, um, TQ8030 was used to develop analytical testing method targeting 43 odorous compound associated with the municipal solid waste operation using the single air sample, and the whole air sampling with vacuum canister equipped with Cyclotech lining was being used to capture the trade gases from um, the municipal solid waste landfills. And this method involves collecting gaseous samples without losing any original constituent, offerings simplicity and quick sampling of the large volume. The multiple reaction monitoring MRM mode, an attribute of the triple quadruple mass spectrometry detection, were used to monitor and target and analyze specific fragmentation transition that lead to increase in sensitivity for the analyte of interest to the characteristic structural link that is meant during the process between the mass selective precursor ion and the products ions. The use of MRM allow for characterization for specific data analysis, and so because of that, we can characterize the canister easier since we collect the sample from landfill, and we don't know what exactly in the canister. So in the MRM method, first you will select a target molecule that you want to detect measure. Then you will identify a specific fragment of that molecule that is unique and characteristic called transition. And in the mass spectrometer, you will set up a monitor the transition of the molecule to its fragment. And this means you are watching a particular change in mass as the molecule breaks apart. Once we are sure that the scan window is good at for peak separation and peak shape, the optimization tool will use to generate our MRM MS parameters. So moving forward, this table and chromatograms is the limit of detection of multiple compounds found in landfill. At UC, by using our methodology, we are able to characterize multiple compounds from the landfills. In conclusion, landfills gases however um um various landfill gas contain various odorous compounds such as VOC, sulfur, nitrogen-based compound, and VFAs. In our innovative detection approach is adept as identify various compound types simultaneously, underscoring the importance of establishing the LOD to guarantee the perceptibility within the human olfactory range. Moreover, our utilization of the GCMS TQ30 8030 analytical instrument, coupled with vacuum canister line with Sacotec, ensure that the preservation of reactive compound and the integrity of our sample. Furthermore, the implication of the MRM method significantly boosts sensitivity by mitigating chemical noise, therefore enhancing the precision and reliability of our analysis. Thank you for listening.